All right, students, this is the first set of notes in the Atmosphere and Weather Unit, which is ES11. This set of notes is called Atmosphere Basics. Not all planets have an atmosphere, but lucky for us, Earth does have one. Earth's atmosphere is also unique because it contains significant amounts of oxygen. That's what we breathe. The atmosphere has 5 distinct layers. The troposphere, where we live, is closest to the crust, and this is where weather occurs. Above the troposphere is the stratosphere, which is just above the clouds. This section features the ozone layer, which protects us from harmful UV rays. Above the stratosphere is the mesosphere. The mesosphere is the middle layer where meteors usually burn up. The thermosphere is above that. Thermo, of course, means temperature. And this layer exhibits the greatest temperature rise. If you look at the graph on the left, that um, shows the temperature going up significantly in the thermosphere. And then the exosphere is the transition to outer space, and you find satellites in the exosphere. Another special layer is the ionosphere. The ionosphere is actually part of the thermosphere. In this layer, ions get electrically charged by solar radiation, and it causes shimmering auroras in northern latitudes. So sometimes if you're up in Alaska or Scandinavia, you can see auroras like this, colorful in the night sky. Air pressure is the force exerted on the surface by the weight of the air. At the surface, there's the greatest concentration of air molecules and the most atmospheric weight on top of it. Therefore, the greatest pressure is at the surface. I think of us living at the bottom of an ocean of air. If you've ever swam to the bottom of a pool, you feel your ears, um, the pressure on your ears. The pressure is greatest at the bottom of the pool, and we are at the bottom of an ocean of air. Air temperature in Earth's atmosphere fluctuates in each layer. The red line in the graph on the right represents the temperature in each layer, and it goes down in the troposphere. The further up you go in the atmosphere, as long as you're within the troposphere, the colder it gets. So the surface is in the troposphere, mountains are in the troposphere. So if you go to a mountaintop, it's usually colder. That's why some mountains have ice caps. But then, as you get into the stratosphere, the temperature starts to rise with altitude. And then you get into the mesosphere, and it goes down with altitude again. And then in the thermosphere, it gets really, really hot with altitude. Here's just another graphic representation of the same thing. Another special layer is the ozone layer. A gas called ozone in the stratosphere is responsible for blocking some of the sun's most harmful rays, UV radiation or ultraviolet radiation. If we didn't have the ozone layer, ultraviolet radiation could cause damage to the cells of living things, including us. The greenhouse effect. Some sunlight that hits Earth is reflected. Some becomes heat. CO2 and other gases in the atmosphere trap heat, keeping the Earth warm. Other gases in the atmosphere play a role in trapping heat. Carbon dioxide, methane, and water vapor are the primary greenhouse gases. This trapping of heat is called the greenhouse effect because it works like a greenhouse. A greenhouse is a house made out of glass, which is used to trap heat in order to grow plants. A greenhouse traps the sun's heat inside of a glass structure. Our atmosphere traps heat as well, and that keeps things on the planet warm for life. The greenhouse effect is a good thing. Without it, the planet would be quite a bit colder. Here's another picture representation of the same thing. The sun is always shooting energy out into outer space. The Earth is capturing some of that energy, and it gets trapped in the atmosphere. That is the greenhouse effect. But some of that energy is also absorbed by the Earth. Some of it's reflected back to space. Um, but the part that gets trapped in the atmosphere, that is the greenhouse effect. The atmosphere is essential for life on Earth to flourish. The oxygen allows aerobic organisms to breathe. The ozone layer protects from the sun's harmful rays. And the atmosphere traps enough of the sun's energy to keep temperatures warm. The different gases in the atmosphere, it's mostly nitrogen. After that, the next biggest gas in the atmosphere is oxygen. Everything else besides nitrogen and oxygen is just 1%. And that 1% is divided into argon, carbon dioxide, methane, and water vapor, and then very small amounts of other gases. But this has not always been the case. As we learned in the geologic time unit, um, the composition of Earth's atmosphere has changed over time. The proportions of the various gases in Earth's atmosphere can change and have changed over geologic history. Interactions between the atmosphere, the biosphere, the hydrosphere, and the geosphere can lead to inputs and outputs. The fact that we currently have 20% oxygen is a fairly important factor in human survival. Human activity is also changing the composition of the atmosphere by burning fossil fuels. More on that later. So that's the basics of the atmosphere. Here's what your notes will look like if you type it all up on one slide, or use my fill in the blank, or you can handwrite it.